Study Grip Gateway to Digital Knowledge.
Dear students, today we learn about Avogadro's number. Avogadro's number, Na, is equal to 6.0210 raised to power 23 particles theorized by Amadeo Avogadro, later mathematically proven by Stanislaw Cannizzaro, around the 1750. Avogadro's number has been experimentally determined to be 6.0210 raised to power 23 molecules gram per mole. Dear students, you know that in our daily life we use different units to express different quantities, as there are 12 units in a dozen. There are 2 units in a pair. In such way, 1 mole of any substance always contains 6.0210 raised to power 23 number of particles, called Avogadro's number. More interesting examples in our daily life. There are 12 months in a year. There are 30 days in 1 month. There are 1000 grams in 1 kilogram. There are 1000 meters in 1 kilometers. As in chemistry, there are 6.0210 raised to power 23 number of atoms in 1 mole of element. There are 6.0210 raised to power 23 number of molecules in 1 mole of molecule. There are 6.0210 raised to power 23 number of ions in 1 mole of iron. There are 6.0210 raised to power 23 number of formula unit in 1 mole of ionic compound. 6.0210 raised to power 23 is called Avogadro's number and can be defined as the 6.0210 raised to power 23 number of atoms, number of molecules and number of ions present in 1 gram of atom, 1 gram of molecule or 1 gram ion, respectively, is called Avogadro's number. It is denoted by Na. Its value is 6.0210 raised to power 23. Dear students, first of all, learn about number of atoms. 1.008 gram of hydrogen atom is equal to 1 mole of hydrogen element. It always contains 6.0210 raised to power 23 atoms of hydrogen. 23 gram of sodium is equal to 1 mole of sodium element. It always contains 6.0210 raised to power 23 atoms of sodium. 238 gram of uranium is equal to 1 mole of uranium element. It always contains 6.0210 raised to power 23 atoms of uranium. Different elements have different atomic masses. These different masses of different elements are equal to 1 mole, and 1 mole of any element contains same number of atoms, which is equal to Avogadro's number, 6.0210 raised to power 23. Dear students, just like elements, 1 mole of different compounds have same number of molecules. 18 gram of water is equal to 1 mole of water molecule. It always contains 6.0210 raised to power 23 molecules of water. 180 gram of glucose is equal to 1 mole of glucose molecule. It always contains 6.0210 raised to power 23 molecules of glucose. 342 gram of sucrose is equal to 1 mole of sucrose molecule. It always contains 6.0210 raised to power 23 molecules of sucrose. Dear students, in this way, 1 mole of different ions has different masses and contains same number of ions. 62 gram of nitrate ions is equal to 1 mole of nitrate ions. It always contains 6.0210 raised to power 23 nitrate ions. 96 gram of sulfate ions is equal to 1 mole of sulfate ions. It always contains 6.0210 raised to power 23 sulfate ions. Relationships between amounts of substances and number of particles. Number of atoms of an element is equal to mass of element divided by atomic mass and multiplied by Avogadro's number. Number of molecules of a compound is equal to mass of compound divided by molecular mass and multiplied by Avogadro's number. Number of ions of ionic species is equal to mass of ion divided by ionic mass and multiplied by Avogadro's number. Dear students, now we learn about how to calculate number of atoms from known mass of compound. Let us have 18 gram of water. We know that 18 gram of water is equal to 1 mole of water. Number of water molecules in 18 gram of water are equal to 6.02 10 raised to power 23. Number of hydrogen atoms in 18 gram of water are equal to 2 multiplied by 6.02 10 raised to power 23, as 1 molecule of water contains 2 hydrogen atoms. Number of oxygen atoms in 18 gram of water are equal to 1 multiplied by 6.02 10 raised to power 23, as 1 molecule of water contains 1 oxygen atom. Total number of atoms in 18 gram of water are equal to 3 multiplied by 6.02 10 raised to power 23, as 1 molecule of water contains 3 atoms. Now, suppose we have 98 gram of sulfuric acid. 98 gram of sulfuric acid is equal to 1 mole of sulfuric acid. Number of sulfuric acid molecules in 98 gram of sulfuric acid are equal to 6.02 10 raised to power 23. Number of hydrogen atoms in 98 gram of sulfuric acid are equal to 2 multiplied by 6.02 10 raised to power 23, as 1 molecule of sulfuric acid contains 2 hydrogen atoms. Number of sulfur atoms in 98 gram of sulfuric acid are equal to 1 multiplied by 6.02 10 raised to power 23, as 1 molecule of sulfuric acid contains 1 sulfur atoms. Number of oxygen atoms in 98 gram of sulfuric acid are equal to 4 multiplied by 6.02 10 raised to power 23, as 1 molecule of sulfuric acid contains 4 oxygen atoms. Total number of atoms in 98 gram of sulfuric acid are equal to 7 multiplied by 6.02 10 raised to power 23, as 1 molecule of sulfuric acid contains total 7 atoms. Now, suppose we have 9.8 gram of sulfuric acid. 9.8 gram of sulfuric acid is equal to 0.1 mole of sulfuric acid. Number of sulfuric acid molecules in 9.8 gram of sulfuric acid are equal to 6.02 10 raised to power 22, or 0.1 multiplied by 6.02 10 raised to power 23. Number of hydrogen atoms in 9.8 gram of sulfuric acid are equal to 2 multiplied by 6.02 10 raised to power 22, or 0.2 multiplied by 6.02 10 raised to power 23. Number of sulfur atoms in 9.8 gram of sulfuric acid are equal to 1 multiplied by 6.02 10 raised to power 22, or 0.2 multiplied by 6.02 10 raised to power 23. Number of oxygen atoms in 9.8 gram of sulfuric acid are equal to 4 multiplied by 6.02 10 raised to power 22, or 0.4 multiplied by 6.02 10 raised to power 23. Total number of atoms in 9.8 gram of sulfuric acid are equal to 7 multiplied by 6.02 10 raised to power 22, or 0.2 multiplied by 6.02 10 raised to power 23. 1 mole of sulfuric acid upon ionization produce 2 moles of hydrogen positive ions and 1 mole of sulfate negative ion. So, total positive charges in 9.8 gram of sulfuric acid is equal to 2 multiplied by 6.02 10 raised to power 22. Total negative charges in 9.8 gram of sulfuric acid is equal to 1 multiplied by 6.02 10 raised to power 22. Thanks for watching. For more updates, download Study Grip app from Google Play Store.